focus is learning terminology. Again, some of these things you've already seen. You're just going to see them represented in a different way. Okay. So we are going to introduce the idea of monomials and polynomials with a little example. Okay. The cost of admission and parking for a museum and an aquarium is given. Here's the signs. We're going to find how to represent the total cost of M people in N cars visiting only the museum, and then only the aquarium, and then both. How would I represent, and again, right now, this is not necessarily new. How would you represent the total admission cost for M people who went to the museum? Take a look at the information for the museum. How can you represent the admission?
15.
15.
Oh, no. Like maybe 15x.
You could use a variable. So here, we're going to use this variable, 15M. Absolutely. Why 15M? What are you doing every time somebody else comes to the museum?
$15.
Yeah, another $15. Absolutely. And how about the parking? If N
Plus
cars
5.
showed up, just 5?
No,
Plus
not
5. Wait.
5 and
Oh, N.
5N, yeah, because it's not just $5, it's $5 for every car. Perfect. How about for the aquarium?
20.
20. Again, we'll use the variable M, but you have the right idea. If you weren't told to use a certain variable, you're correct. $20 times whatever represents the number of people. And how about the cars at the aquarium?
6N.
6N. Good. So now let's say we wanted to put it all together. We had 15 per person, and then $5 per car, and then 20 per person, and $6 per car. How would I represent the cost for just the museum?
15.
Just 15M?
15 plus 5.
Yeah, why do I have to add them together? Like, why isn't it 20?
Because
they're different variables.
The variables are different, absolutely. And how about the aquarium? How would it represent at the aquarium?
20M plus 6M.
Good. Now this next slide is a little bit of a stretch. Just kidding. If we wanted to do everything together, if these were the two expressions and I wanted to take them both and combine them, what could I combine? I could combine all the M's. So how many M's would I have? 35. And how many N?
11.
Oh, I'm sorry, this one's 5. So it is 11. Now, that part, I don't love that part because I can't just assume that my total cost is going to be 35 times M. If that were the case, what do I know about the number of people that went to the museum and the aquarium on that day?
They paid $35 and $11 for parking.
So the museum was 15 a person and the aquarium was 20. If I wanted to add the 20 and the 15 to get 35, what do I know about the value for M?
How much money they pay per person?
That would represent the coefficient.
Alright.
And the M is the number of people. If I'm able to say that M people went here and M people went there, technically I'm saying that's the same number if I'm using the same variable. That extension here, I don't love. But still, it's an introduction to polynomials and monomials because what did you just do? You took a real situation, you applied variables and coefficients essentially, and you represented a situation using mathematical symbols. We can model a situation like you just did with expressions. The expressions that we just used were monomials, so this would be the first definition on your table. A monomial is a real number, a variable, or a product of a real number, and one or more variables with whole number exponents. If you want to summarize any of these definitions, you can. You don't have to write every single word. Examples underneath, those are examples of monomials. So we have the number 18, the variable z, the term negative 4x squared, 2.5xy to the third, or a divided by 3. For those of you that have an appreciation for English and root words, the prefix mono represents what? What do we think of when we see the word mono? Yeah, one. Well, in Spanish, mono is actually monkey, right? Yeah, that's right. I'm on Duolingo. But mono, if we had mono at the beginning of a word, that typically means one or single. The word meal would represent term. So if I had a monomial, I really have a single term. At this point, that's not new, because when you've been working with expressions, you have learned before, we've talked briefly this year, that each part of an expression, everything that's separated by an operation symbol, is a term. So that's what we would call a monomial. So think about if monomial is one term. Without calling it out, think about what a polynomial probably represents, because that's going to be on our next slide.
So what?
Well, polynomial sounds like poly.
So, okay, think about the word polygon. What do you know about polygon?
Multiple.
Multiple, exactly. Is anyone right?
Wait.
Okay.
That's good.
You will hear me refer to these words, monomials, polynomials, as we move forward. So it's important to take this time at the beginning just to at least identify what they are.
So this whole time you've been working with monomials?
Yeah, without even calling them monomials, you've been working with terms, mostly terms like this. But those are monomials because they are really a real number, a variable, or a product of a real number and a variable. Whole number exponents, we have done some stuff with fractional exponents, so those wouldn't be considered monomials, but we will get to that in Algebra 2. So a polynomial, and I know it's a lot of writing today, but a lot of you already said it. You knew that prefix, that word poly, represents many. You could probably come up with a lot of other words that start with poly, but a polynomial is an expression that has constants, variables, exponents. You can combine them, and again, you're able to summarize this, that's fine. You don't have to write every word. You can combine monomials using addition, subtraction, multiplication, and division, and that represents a polynomial. So if you look down here, these are 4 monomials, 4 individual terms being added together or combined. This makes the polynomial. And for those of you that know root words, poly means many. And then meal, or no meal, would be terms. So a polynomial just represents many terms, more than one. You've also worked with polynomials before. Think about 3x plus 7. Technically, that's more than one term. You're not going to be asked to define these. Our work in this unit is going to be just calculating, but you will hear me use these words, and I don't want you to be like, what is she talking about when she talks about adding polynomials? Again, these are things, this is not necessarily new. It's just a new word. But it's something that you've worked with before. So the polynomial is really just a combination of monomials. If you wanted to summarize it in the simplest way, polynomials are just many.
Jennifer Monomials to the main office immediately.
A polynomial is just many monomials together, whether you're adding them, subtracting them, or multiplying them, or dividing them.
So a polynomial, a monomial and a polynomial.
Yes, absolutely. A polynomial is really just made up of like monomials. Yep. Now you can name polynomials. You'll probably use the names of them more than you would just the term polynomial. You don't have to write it down. It's things that you will experience as we go. Am I good to slide, or do you need more time? I'm going to skip over this because you guys knew that prefix right away. Zara said, sounds like polygon. Absolutely. This entire thing, and I do this because I like to tell my school that sometimes we cover English concepts. The prefix poly represents many. So when we talk about a polynomial or polysyllabic or polygon, we're talking about the idea of many. So here, the degree of a polynomial, the degree of a monomial, is the sum of the exponents of its variables. So in this example here, the degree of this monomial is 4 because the exponent is 4. The degree of this monomial is 2 because the exponent is 2. The degree of this monomial is 1 because x doesn't have an exponent, it's an understood 1. And then the constant has a degree of 0 because there's no variable, there's no exponent.
I thought it was 0 because I think that the 0 power was 1.
That wouldn't be the reason. The reason here, if we know that the degree of the monomial is adding up the exponents, if there is no exponent, then our degree would be 0. Like if there is there's no variable to have an exponent. Because technically, that would be a 1. So 5x, what would the degree be? 1. Good. How about the number 4? 0. How about this?
2 and 3.
5.
So this degree would be 5. Now let's see what that means.
What? How do you
Which
change?
one?
How do you change?
Hold on, we're not changing. This is something new. You've never learned about the degree yet. You want me to restate it again?
Yeah.
Okay. The degree of a monomial helps to name it. Okay, and you'll see what I mean in a few minutes. Whether something is quadratic or cubic or to the 4th degree, it all has to do with the exponent. So we can actually,
That one has no exponent.
which one?
4.
Yeah, there is no exponent, so that would be 0.
So if I had like a 5.
Any constant has a degree of 0. There's no variable, there's no exponent, so that would be 0.
Oh, so how many? Oh, yeah.
So you're adding. So here, there technically anything, if I just had x, it would be x to the 1st, which is why this is a 1.
Yeah.
Here, I can add the 3 and the 2. That's where I'm getting the 5.
Oh.
And then here, there's no variable, so I have no exponent, which is why I have a 0. Now, this will come in handy. You'll probably have some type of, what's the degree of this term? But the reason we use this is to name them. We already kind of talked about why this would be a monomial, why a constant would have a degree of 0, so I'm going to skip over that. These are the last 2 things you're going to have to write. I know it's a lot of writing, I'm sorry. The polynomial at the top is in standard form. This is something that will eventually come naturally, but when we do our work with polynomials, typically we put them in standard form. What that means is we put the degrees of the terms in order from the largest to the smallest. Something you've actually done before, like if you show a linear equation and you've done 3x plus 4, a lot of you see that as the way it quote unquote should be written instead of that.
Yeah.
Not that either one is wrong, but a lot of us do this anyway. We start with like the biggest one, and then we start to write them as they get smaller and smaller. This is in standard form. The largest degree is first, something x to the 4th, and then we have the x squared, and then the x, and then the constant. So that polynomial is made up of 4 monomials, and we put them in order from like the large, and I don't want to say largest in terms of size, I mean largest in terms of exponent. We had the x to the 4th, and then the x to the 2nd, and then the x, and then the constant. That would be standard form. And then the last thing, the degree of the entire polynomial is the degree of the largest term. So you can look right here for the degree of the polynomial. The largest term's degree is the degree of the whole thing. On Monday, you'll see some examples. I'm going to have you do a couple practice problems of finding what the degrees are and putting them in standard form. You'll get some practice of that on Monday. You're not going to practice that today. we can name polynomials based on that degree. And I'm going to show you what I mean on the next slide. It's not something you need to write down. It's something you'll see again. It is actually an image that I pulled from the textbook that is underneath your desk. A lot of these lessons I pull from that textbook so that you can reference back if there's anything that confuses you. Are we good, or do we need a little bit more time to write?
What would be an example of like standard form of a polynomial?
We're going to actually, this is technically right here, standard form of a polynomial. This is multiple terms together, and the reason it's in standard form is because we have the largest exponent, and then they get smaller as they go. Something that would not be in standard form would be like 2x squared plus x to the third plus x. And the reason that's not in standard form, this being the larger exponent, should be first. So this would not be in standard form. You do not have to write this down, but this is the reason why the degrees and the number of terms matter. You can actually call a polynomial by its real name. Right? So an example of this, a constant, just a number by itself. It doesn't have its degree is 0 because the term by itself has no exponent. And that's a monomial. It's just one term by itself, no exponent, it's a constant. Okay? The expression 5x plus 9, that has two terms in it. The 5x is a term and the 9. So we can call that a binomial because there's two terms. But the degree of their largest exponent is a 1, so that's called linear. And that's what you've been working with since you've been in, whatever grade you started working with expressions, 4th and 5th grade.
Call it a linear.
So that would be that's a linear expression. If you wanted to name it by the number of terms, that is a linear binomial because there's two terms.
Well, it's like linear, is that where like the term linear equation like that?
Yes. Everything that you've done in 8th grade was linear because all of your variables only had an exponent of 1. We didn't have any x squareds or x to the third. We were only graphing y equals 2x plus 4. That x was still singular. This next row is actually what we focus on most in Algebra 1. There are 3 terms in that expression, so we can call it a trinomial. Tri meaning 3, nomial still being terms. There's 3 terms, so it's trinomial. But this is quadratic because the largest exponent is a 2. The larger exponent of a 2 refers to quadratic. So most of what we'll do for the rest of this year, we'll be focusing on quadratic because we focus on x squared. And we do a lot of work with trinomials. We'll work with binomials and trinomials in this unit. And we do a lot with quadratic. We don't do a lot with cubic. Cubic would be to the 3rd power. So this is cubic, even though it's a monomial, it's by itself. It's cubic because it's x to the 3rd. And in this last one here, there's 3 terms, so what would I call it?
Trinomial.
A trinomial, and it's got a larger exponent. The largest exponent is a 4, so it's to the 4th degree. There's not a fancy name for that one. Again, you don't have to memorize these. You'll hear me constantly say, if there's 3 terms, what do we call that? If the larger exponent is a 2, what do we call that? I'll constantly bring that up to help you reinforce that terminology. So, is this expression in standard form?
No,
Why not?
because the biggest exponent is on the right side.
Yeah, our larger exponent isn't first. How would could I just change the order?
Yes.
Why?
Yeah.
Because it's on the
Commutative property. So what would that be in standard form?
4x to the 2nd plus 3x.
Could I name that?
Binomial.
It is a binomial because there's 2 terms. What kind of binomial is it? Quadratic. Good. Again, you don't have to know this right now, but some of it might start to become more and more familiar. That is a quadratic binomial. It's 2 terms, and the larger one has an exponent of 2. Perfect.
Why is it called quadratic?
Yeah, that's what I was
Yes.
thinking.
I'll be honest.
Like
I
a
don't
quad.
know. Quad reminds me of 4.
Yeah,
I know.
quad.
I know. I agree. I will look it up and find out.
Is there
more
like a
like-
specific reason?
You just.
I don't know. I I really don't. I will look it up though over the weekend and try to find out. You guys always ask really good questions like that make me go home and look
Maybe
stuff
it's
up.
like 4 things, like the 4 is 1, and then the x squared is 2, and then the 3 is 3.
Retry.
Right, try,
And then
like
the
the
X
bi and the try I get, but when I think of quad, I think of 4, not 2.
4.
But I guess over time, because I know quadratics are represented by that squared, for me, like it's changed a little bit in my mind. But I really don't know, and I will find out. For the bottom one, how do I put that in standard form?
5x.
Yep, the 5x to the third will go first.
Plus 7x.
7x.
Minus 1.
Think back to any other grade level before this one. If you had an expression like that, how many terms are there?
Like 10.
Yeah,
In this expression right here, how many terms do we have?
Yeah.
Why do you think 3?
Because there's an exponent.
How many signs
I said
there are?
Okay, so there is an exponent, but how many actually count the number of terms in it? How many do you see?
I see 4.
So most people will say 4 because what are the terms? Yeah, this is a term, this is a term, this is a term. Right, so you would say 4, but what could you do?
Combine the like.
Yeah, technically, right? If I have the 7x and the 4x, just like you've done in previous grade levels and earlier this year, you could rewrite that as 11x. So if we're talking about the number of terms, you have 3 in standard form. What kind of trinomial is that? Based on the degree,
Is it cubic?
because the largest exponent is the 3, you could call that a cubic trinomial. Again, if those words aren't clicking yet and you're seeing like the exponent of 3 and you're not sure what to call it, that's not a big deal right now. Don't worry. I like to kind of give you everything up front and then we'll break it down and get really comfortable with it as the month goes on. You will practice putting expressions in standard form and identifying if they are cubic or quadratic or linear on Monday. We already did these, so I'm gonna switch down. So now we're gonna talk about adding and subtracting polynomials. Okay. This is something you have already done. If I were to add, if I said you were gonna add 2 expressions together, what do you think to do? Any expressions, what do you think to add them? What do you think of?
That.
Think of
Something like that.
Okay, and how would you add them? Like when I say you're gonna add 2 expressions together,
System of
System.
okay, so you think of like the 2 equations, and then when you add together, what do you have to make sure of when you add?
Same.
Add like
Yeah.
Like terms. Same thing here, right? When we add polynomials together, you are combining like terms. The trickiest part of all of this is making sure that the terms are like, because now what do you see? You don't just have x and constants. Now you have an x, you have an x squared, you might see an x to the 4th at some point. So you have to really keep those like terms clear. We're gonna represent the total between the campground rentals and the backcountry rentals. This is just an example. They tally National Park Service over 5 years, and these are the models, and they want to figure them out combined. So if I know I'm going to combine them, you already said if you combine, you think about adding like terms. So that's what we're going to do. We can do this 2 ways. What kind of expression is that? What would you call that? It is a trinomial because there's 3 terms. Good.
Quadratic.
And it is quadratic because the largest exponent is a 2. Good. How about the second one?
Same.
It's the same.
Quadratic.
It's also a quadratic trinomial. Good. We know we're adding here. How do you add? Like, what do you do when you add? Think back. Even when you learned how to add. Like, what did you learn to do?
Combine.
Combine. How do you lay it out?
Line up systems.
Line it up. Yeah, a lot of people learn how to, when you learn how to add, you were taught like line it up. Or you made sure place value was there, and you lined it up. Okay? Do we always do that? Not always. Right? You have some strategies for adding. And this might seem really silly because some of you are like, I know how to add. But when you have different exponents, it matters the strategy that you're going to use. It's all about your preference. So you could add vertically. if I add vertically, what do I have to make sure I do?
Line up everything.
Everything has to be lined up, because what would happen if my first term here was an x to the fourth? Could I just line it up that way? No, x to the fourth and x squared are not like terms, so I have to make sure. This one works out really well because the terms are like, I can line them up this way.
Are we gonna be using other exponents like 4 and 2?
For practicing adding and subtracting, you'll see some examples of larger exponent numbers. When we start to multiply and factor, not as much. So if I combine here, just like you said, you can line it up and you can combine them. Right? What would I have if I combine 5,800 and 1,900? 7,700. Good. How about negative 180 and negative 140?
Negative.
Negative.
3 to 100.
Oh, wait. 0.
And then this one actually took me a while. Negative 7.1 and 21.
Negative 13.9.
It's a positive, but it is 13.9. You're right, the number. Now I can do it this way. You could line it up, absolutely. Think about the drawbacks to lining it up. You have to make sure that what you're lining up actually is a like term. You can't just assume that the first term of each polynomial matches. Still have to make sure of that. Or you could do it horizontally, which we've done a lot like this year. When we've had like a big equation, we simplify. It's typically been in this format, like this expression. You can figure out your like terms, add them. You have the x, you can add them, and then your constants, you can add them. Right? Whatever your strategy is, practice that one when we go through our examples. Okay? They provide options because it depends on how visual you are. Some might be easier than the other. Okay? If I added these together, what my answer is what kind of polynomial?
A quadratic.
It's a quadratic trinomial. You both got it. It is a quadratic trinomial. Do you think if I added two quadratic, this is like a little bit of a stretch. If I add two quadratic trinomials, do you think I will always, no matter what, end up with a quadratic trinomial?
I don't know. I feel like kind of.
Think about this if you're trying to prove if it's right or wrong. Is there some trinomial that is quadratic that I can add to that would give me something that is not a quadratic trinomial?
Maybe.
What do you think? I'll start there.
I was thinking about if you had a negative constant.
Oh, like what?
Like negative 7,700. Like if you had, because then it wouldn't be there anymore.
What would happen?
They'd cancel out.
Yeah, if I actually have an opposite of any term, they would make 0. So in this example, if I had just 1x squared and then minus 100x, right? This would combine, I would have 14.9x squared, and I would have negative 420x. I no longer have that constant, right? I mean, I could show a 0, but I don't have to, right? So technically, that's a binomial now. So it's not always going to be. Don't assume that just because you're combining things, you're always going to have the same number. Something might actually combine to 0. We're not going to talk about preference here. Subtraction's a little different, right? When we add, we know to just put it together. What do we have to be really, the only thing we have to pay really close attention to when we subtract?
Place value.
Place value matters.
Sign.
Signs matter. Why? Can I just say, oh, well, if I'm subtracting that, then I can just take away the parentheses. Can I just do that? No. Why not?
Because you have to do all the parentheses.
I have to use order of operations. I have to make sure I'm subtracting everything. So so far this year, again, not something new. If you had a negative symbol or that subtraction sign outside of a parentheses, what do you do with it?
You leave it there.
A lot of times we've distributed it. No, a lot of students have said, okay, that's a -1, so I'm going to distribute, right? And that changes things because it's not a positive 5x squared, it's a negative 5x squared, and we're not subtracting a negative is the same as addition. That's why those symbols change. So we have to be really careful. When we subtract using, I'm going to skip over this. if we subtract, another thing to be really careful of here, we have something to the third, something to the second. There is nothing here that lines up, if we do vertically, with 5x, because a constant and a linear expression are totally different. So notice when I line it up, I do have some gaps here. That's okay. But when I subtract, that idea of distributing needs to come into play. If you choose to do this vertically, you would need to represent this negative symbol. This would become a negative, and this would become a positive. Because subtracting everything changes the signs. So here, if I had x cubed and I subtracted 7x cubed, I would have negative 6x cubed, negative 3x squared minus 5x squared. Good, negative 8x squared. 5x, doing nothing to it. Positive 12, doing nothing to it. We're there. Again, that's not different. Right? You've learned how to combine things. The only difference with subtraction is that negative symbol would need to be either distributed or however you see and visualize subtraction using multiple terms, whatever you see would be done that way. If you saw it horizontally, most of you at this point do distribute that negative. Negative 7x cubed minus 5x squared plus 12. And most of you from there do combine. A lot of you see it this way. You say negative 6x cubed. Negative 3x squared minus 5x squared. There's nothing with the 5x. There's nothing with the 12. Horizontally, most of you have had more practice horizontally this year. In your past, you've lined stuff up when you didn't really have coefficient. In the past, I know. Now I pay attention when I do that. But a lot of you in the past, when you lined stuff up, you were just lining up constants, like just numbers and place value. This year and like the last year or two, when you've been working with equations, you've done it horizontally. Whatever you want to do is completely fine. You can choose. So before we get here, okay, I just want you to take a look at, and you know what, I'm going to leave my writing up. I'm going to pause it here and then we're going to do our DOL. But you just take a look at the methods. You don't have to tell me what your preference would be in terms of adding or subtracting, but when you go through the practice problems, and there are a few, the practice problems are set up so that some of them will ask you to do them horizontally and some will ask vertically. Moving forward, once you practice, you don't have to do them a specific way. As you're learning how to add and subtract polynomials, find what feels best for you. That's my recommendation. Now, we are going to do 3 things, and we actually are at a really good point in time because the bell's going to ring right about now. So I'm going to pause this.